All right, this is the first video in a new packet. The title of this packet is Applied Genetics. And in this packet, we're going to be looking at how genetics affects us in our day-to-day life. So we're going to be talking about things like diseases that are specific to humans. We're going to be looking at things called pedigrees that show you inheritance patterns, how we get change through things like mutations. And then finally, we're going to wrap it up with electrophoresis, which is how they test DNA of humans. So if they say, oh, we found your DNA at the crime scene, they analyzed it through a process called electrophoresis. But to start off with, we're going to talk about some diseases, and we're going to talk about diseases that are what we call sex-linked. So I always like to start off with a story of this family. And it's a little blurry, so I do apologize for that. But this is the last ruling family of the country of Russia. This is Tsar Nikolai. This is his wife. These are their children. This is Anastasia, and this is their son, Alexei. Now, this dynasty had ruled for hundreds of years, and it passed from father to son to father to son. And this was the only son that they had out of their 5 children. Now, the problem was he had a disease. His grandmother was Queen Victoria of England, and she was a carrier for a disease called hemophilia. So one of the diseases we're going to be talking about is hemophilia. And in that disease, your blood doesn't clot properly, and you can die if you fall off. He was sledding one time, and he fell off a sled, and he got internal bruising. And bruising is just bleeding underneath the skin. Because his blood wouldn't clot, he just kept bleeding, and he almost died. And it was so important for them to have a son to carry on this hundreds of years of tradition. Well, she was really freaked out, and it turned out there was a monk, and his name was Rasputin, and she believed that he had magical and curative powers and could heal her son, but he was hated by everybody except for her. He was a drunkard, and he would run around with women, and people, both the nobles and the serfs, the lower classes, hated this guy. And together with World War I and some other factors and the presence of Rasputin, who was there because her son had hemophilia, these guys were overthrown and eventually they were executed. So, but a lot of that ties back to the fact that Rasputin was there because of this sex-linked disease. So these diseases aren't small things, and sometimes they change the course of history. Another one we're going to look at is color blindness. And color blindness. And from what we've talked about before, we're going to see that a sex-linked trait is going to be more dominant in males than females. So let's go back through what we know about sex chromosomes. Sex chromosomes. So we know that females have 2 X's and a male has an XY. Now, what we said in the last chapter when we talked about codominance is that when we have 2 pieces of information, we're going to do a base and then we're going to do an exponent. So these boxes represent where the exponents are going to go. Well, why don't we have a box around the Y chromosome? Because when we're talking about a sex-linked trait, we're talking about traits that are carried only on the X chromosome. Only on the X chromosome. And so this Y chromosome does not carry an allele. In fact, when we talked about chromosomes, we said that Y chromosome kind of doesn't do a whole lot. It doesn't have a lot of genes on it. There are some genes, of course, and the genes for developing testosterone are on there, but there isn't a lot. So if we were going to, let's do a cross for color blindness. So let's say that capital N is normal vision. And let's say lowercase n is colorblind. So let's say we have a female, and remember we have to write her 2 sex chromosomes. And then we're going to put the trait as an exponent. And we're going to make her heterozygous. When we have a female who has one normal trait and one disease trait or condition trait, we call this being a carrier. Because she carries the trait, but she's not afflicted by the disease. And as a carrier, she can pass it off to her offspring. And let's say we have, we're going to cross that with a normal male. So a normal male is going to be XY. And he is going to be normal. So these are now our genotypes for our female and for our male. But what we have to understand is we have to put two pieces of information in here. We have to have their sex chromosomes, and then we need to have the alleles that are on the sex chromosomes. So if we had a female, she would have, so if she had two X chromosomes, remember the allele is an area on the chromosome that contains a portion of DNA that codes for a protein. But on the male, his genotype, he's going to have an X chromosome. Whoops. But then remember that Y chromosome is kind of short. It doesn't do a whole lot. So the male only gets one copy versus the female that has two. And by putting it in this form, we can see that. So we have the base and then we have the exponents. And it's really important that you understand the base and exponent. So let's do that cross and see what happens. Oops, geez, I'm having a rough time this morning. And I'm going to write their genotype. So let's put mom up here. She's XX. And then I'm going to add her alleles. So I've got a capital N, lowercase n, and I've got dad who's XY. The Y does not carry an allele, and his X chromosome is normal. Okay, so when I do this cross, I get the first potential offspring is XX, so it's a female. And I've got a capital N, completely normal. The next cross is XX. I've got a capital N and a lowercase n. So that's a female who's a carrier. So in this box, I have a normal female. In this box, I have a carrier, female. Now look what happens. Now I have XY. This isn't a female, this is a male. And he is going to have capital N, so he's normal. Now I bring down my X and I bring over my Y, but check this out. I've got that lowercase n, so I have an afflicted male. And when you're looking at a sex-linked cross, what you have to do is you have to understand, you have to divide it between the females on the top and the males on the bottom. So you can't just look at your offspring overall. So if we have a female, we have a 50-50 chance of being normal or being a carrier. If we have a male, if we have a son, now we've got a 50-50 chance of being normal or being colorblind. So you can see that not having that second allele really does have a pretty big impact on the ability of men to tolerate sex-linked diseases, because they only have to get, for a female, she has to get double of the alleles in order to exhibit the disease, but a male only has to get one. And since he only has one copy, he doesn't have that protection. All right, so we're going to do this one in two parts. And in the second part, we're going to look at some sample problems. All right, so on to the practice problems.